Hello, everybody. Today we're going to be talking about how to find the exponential best fit model given a set of data. We're going to be looking at it in Desmos, so if you want to have that pulled up so you can work through it with me. I'm going to use the NC testing version because that's always the one that is going to have your options that you're actually going to be allowed to have on your final exam. So just a quick review, when we're talking about the exponential best fit. So remember our form for an exponential is y equals a times b raised to x, and x is that variable. The a is your y-intercept, that's your initial value in a real-world application. And the b is the base, which is the growth or decay factor, but it can also be called the common ratio. Okay, that's that number that you're going to be multiplying by each time. So, just to review some steps in putting this into Desmos, the first thing you're going to do is you're going to click that plus button. And when you click that plus button, it's going to give you an option to click table. Okay. Now, once you have put in your x and y values, we're going to put in the formula y1, that similar symbol. I use the word squiggle in class just because that's how kids remember it. A times b raised to x1. Now, the reason we're using a y1 and an x1 is because that's how it's labeled in the table in Desmos. The thing for this one, though, is we need to make sure we click log mode. That is going to give you the most accurate information. So make sure you click that, or some of your pieces may be off a little bit. And then, of course, we're going to use our A and our B that they give us, and we're going to write that best fit model. And we're going to use that best fit model to make some predictions about the information given. For our first problem, it says the table shows the number of bacteria present in a certain culture over a 30-hour period, where X is time in hours and Y is the number of bacteria. So it says write an equation for this set of data. So when I look at this, I'm going to follow that process again that we talked about, the steps with Desmos. So I'm going to hit the plus sign, and I'm going to add the table. And again, it should say X1 and Y1. If it doesn't say X1 and Y1, you probably have another table in there. You can go on back and delete it. And I'm going to put that information in. I put my X's in. Now I'm going to go back and put my Y's. And in doing this, we want to make sure that we are very careful as we're typing in our numbers. You can easily get the wrong best fit model if you've typed the information from the table wrong. So just always kind of go back through and check your numbers and make sure you've typed them correctly, because it's easy to skip a zero or feel like you've typed something that you actually didn't. So I now have my table. I want to actually look at this scatter plot that is being created, and I'm not going to see that because we have a scale that's a 10 by 10, and we have Y values that are in the thousands. So if you look in the blue side of the table, there's a zoom option that has a magnifying glass with a plus. So if you hit that zoom option, it will actually automatically zoom to the scatter plot for you. And you can see that it's got that exponential curve happening. You can see that it's very steady right there at the beginning between 0 to 20-ish. And then once we hit 20, it starts to increase much more rapidly. So we're going to be looking at this exponential model. Well, in order to find the exponential model, we have to tell Desmos that we want exponential. So we're going to type in y1. Again, we're doing y1 because that's how the table is labeled. We're going to do that similar symbol, which is, I call the squiggle. And we're going to do A times B. And we're going to raise that to, so we're going to do the exponent, x1. Now, it's going to give you information when you put this in, but in order to be accurate information, especially that correlates to your exam, you're going to click log mode, and that's going to change your values for you. And it's going to change them slightly, but it still can make a big difference when you're making predictions. So at this point, I can see that exponential model, and I should be able to write my A. And I always like to use at least 3 decimal places to make sure it's an accurate prediction. I have 861.031, and my B value, my common ratio, I have 1.076. So I'm going to write that equation. So I'm going to put it in that format, y equals a times b raised to x. So I have y equals 861.031 times 1.076 raised to x. That is my exponential best fit model. The next part, in part B, it says describe what relationship. So the relationship we're going to talk about, is it positive or negative? Is it strong or weak? The correlation coefficient, that R value, can actually tell you that information, but you should be able to look at this and draw some conclusions based off of the scatter plot. And my exponential model is going up, so this would be a positive relationship because they're both increasing. And strong or weak is based off of how close to the exponential model it actually is. How compact are my points? If my points are more spread out, the weaker it'll be. The more compact it is together on the line, the stronger it's going to be. And these points are very close to the line, so this is going to be positive and strong. And then finally, we want to make some predictions. So it says predict a number of bacteria where after 6.5 hours. So hours is my x value. So we're going to take 6.5 and we're going to substitute that in for my x value because that's the x value, the hours that we're discussing here. So I have y equals 861.031 times 1.076, and I'm going to raise that to 6.5. Now, I can put that right into Desmos. And I'm going to raise that to 6.5, and I get that my bacteria is approximately 1,386 we'll say 11, and that's going to be bacteria. Now, another way that I could do that is I could recognize that x is equal to 6.5, so I could create that vertical line by typing in x equals 6.5, and I could find that intersection, creating like a system to that problem. Let me zoom in. And I have 1,385.11. So why was it off just a little bit? So probably the reason that this was off was a little bit than what the answer we got was because we rounded. We rounded 3 decimal places, and that could have thrown our answer off just a tad bit. However, we should recognize that it is very close to the answer we got. All right, here is my next problem. It says the number of bacteria present in a lab is growing rapidly. The table below shows the number of bacteria present after each minute. So if the exponential trend continues, how many bacteria are expected to be present after 12 minutes? So in order to make a prediction, we would need to, 1, have the scatter plot, 2, we would need to find the best fit model and then use that best fit model. So pause this video for a second, put this into Desmos, and see if you are able to get the same best fit model that I get for this exponential function. All right, we're back, and I'm going to put this information into my table. And again, make sure you're very careful about typing your pieces because just one piece being off can mess up your whole model. And I'm going to put in y1, my similar squiggle, a times b, and I'm going to raise that to x1. And again, I'm using those because that's the labels that are in my table. Now, if you did not click log mode, make sure you click log mode because that will change your values for you. So I have my a value is 65.11 2.10, and my B value is 2.172. And again, I like to use 3 decimal places when those decimal places are available. So my best fit model, remember we're going to be typing in A times B raised to X. So y equals 65.10 times 2.172 raised to X. That is my exponential model. If you didn't get this, please go back and check your table. Make sure you typed in your pieces correctly from your table, and then make sure you click log mode. Okay? So then it asks us to make a prediction. It asks us to predict how many bacteria will be present after 12 minutes. So minutes is an X value. So we're going to take 12 and we're going to plug it into the X spot. We're going to substitute that there. All right, so I have y equals 65.10 times 2.172, and we're going to raise that to 12. I'm going to type that right into Desmos using my next row. And for this particular time frame, we got approximately 717,627.11 bacteria. All right, so how else can we look at this? Well, obviously I see an exponential model here, but I don't actually see the scatter plot. So we discussed earlier that if you go to the table, in the blue section of the table column, there's that zoom option. It's going to zoom your scatter plot for you. And you can see that we now have those pieces. And again, we said that X was 12. So if I type in X equals 12, and I'm going to have to adjust my screen, so I'm probably going to have to zoom out quite a bit. And we see that happening there. And we finally, and it starts to get so close that it's kind of hard to see that information. The one thing about Desmos, though, is it does find that intersection. So if I'm down here and I click, that point's not going to show up. But as I move closer, the point is going to be that intersection. And they have 715,740.0. And again, we are close, but we rounded our values where Desmos did not. They had more decimal places than we did. So we found that approximately, which is a prediction, but it's not always going to be exact. But it's a way to check to make sure that you were in the same range when you plug that value in. All right, so just a reminder, a couple of things. Make sure you click the plus sign, put in your table. You're going to type in your X and Y values. You're going to do Y1, the similar squiggle, A times B raised to X1. Do not forget to click log mode. And then once you create that equation, you can make predictions from there.